we are going to start up today. Let me get my notes dated here. So we're going to be starting our first unit we're going to be doing here. It's kind of a short unit, not a bad thing. Systems of equations, which means we're going to have more than one equation. And we're going to try and figure out where they have values that are in common with each other. And there's 3 different ways we can do it. We can graph them, or we can use algebra to do substitution or elimination. And the nice thing is a lot of times they're flexible, but there's certain ways that tend to be better depending on the situation. So we're going to focus strictly on the graphing part today. So we're going to graph both lines. If graphing is a dilemma for you, I'm going to show you what you can do on the calculator to get the lines. If graphing isn't a dilemma, you can just jump right in and do it. So here's what I'm going to mention first. We always want to get our equations into y=, form, or this is called slope-intercept form. Because when they're in this form, this is when they're going to be the easiest to graph. Because then I can graph my y-intercept first. Okay, that's what this b thing is. The number on the end is going to tell me where on the y-axis I put my first point. And then we're going to go slope from there. And this is one of those things, again, when we're doing notes, you got to figure out, okay, what parts of this do I need and I don't? If you're a graphing expert already, maybe you don't need this. But if you aren't a graphing expert yet, when we talk about slope, when we talk about rise over run, we're talking about, hey, on the top of my fraction, how much do I go up or down? And on the bottom, how much do I go left or right, depending on what sign the numbers are. So otherwise, we're going to be using the calculator. So on this first one, I'm going to graph the first one using the equation, and the second one we're going to do in the calculator, just so we can see how this works. So, number 1 here, if I did this, my y-intercept, I'm going to shorten this up a little, is -2. Okay, the number is hanging out on its end here on the own. So, I go to my y-axis, and I find -2, and I put a point. Then, my slope is the number in front of x. But if it's not a fraction, 2 is not a fraction naturally, I'm going to make it a fraction by putting it over 1. So, since the 2 is positive, I'm going to go up 2 from this point, and I'm going to go up 2 and right 1. Now here's the thing. Up 2 and right 1. You're like, Hardy, up 2 and right 1. Hardy, why are you still making dots? I have enough dots to make this line already. Because when we're doing systems of equations, we have got to be exact. We have got to know exactly where these cross. And the only way I'm going to know exactly is if my line is like just right. So I'm going to put every single dot on here that I can, including if I run out of room as I'm going up 2 and right 1, I can also do the opposite of both of these and go the other way. So I can go 2 down and 1 left. So if I come back here and go 2 down and 1 left, and 2 down and 1 left, I can literally dot my way through this whole graph, which is what I want to do. And connect the dots. And I've got that one set. Now, if you're an expert in that field, I would say go ahead and graph the next one. But if you are not an expert in that field, you're like, okay, so how do I do this, Hardy? It's been a while. Okay, so let me get out of here for a minute, just in case some of you are like, where did you just do? If you go to y equals up here in the corner, okay, that's going to get you here. If there's something written in there, and a lot of times there will be, all you got to do to get rid of that is hit the clear button, which is over here on the right. Let me get my finger out of the way. So like if there'd have been something in the way, I hit clear, it goes away. And if we got to work on that sum here at the start, we can. So I want to put negative, that's the negative button, that's minus, that's negative. Negative, see the x is right on there, negative x plus 1. And I'm going to graph it. So you're like, well, that's great, but how do I know where all the points are going to be? It's true. So if we need to check the points, we do second graph for points. So we're going to plug the equation into y equals, and second graph gets me the points. So now they've got all these x and y coordinates that I can use. So I can be like, all right, 0, 1, negative 1, 2, negative 2, 3. You're like, Hardy, how many of these have I got to do? As many as you can fit on the graph. And if we run out of room one way, we just go the other. And what you're going to find out when you do that is that you are going to find one spot, one exact spot that the two lines cross. This is why we've got to be so direct with what we're doing. Once I find that spot, that point, I'm going to write the coordinates of that point. So reminder, that point, I want the x value first, which is at 1. That kind of got blended in here. And the y value, okay, I didn't go up or down any, I just scooched over a little. So my coordinate point's at 1, 0. That's my answer. That's where they cross. So that's what we're going to be trying to do here. So again, whether I'm using the calculator or I'm just using my own wherewithal, it doesn't matter. So let's play that one more time here and see. We'll do one of each again. So when I get here, what's my y-intercept on this one right here? Where's my first point going to go? 4. So I go to my y-axis, I go to 4, put me a dot. My slope is negative 1 over 1. Now, here is an interesting fact. People say, well, the negative's in front, so you put the negative on both numbers, right? No, just one, and you can pick which one you put it on. So I put it on both, and it'd be positive. So that negative 1 means I'm going to go down 1, but the positive 1 down here means I'm going to go right. So down 1, right 1, down 1, right 1. And I would suggest probably on the graphing, more than likely using a pencil. I'm being brave using a pen because if I'm wrong, it's going to be kind of hard to erase or change, but And then when I run out of room, we're just going to flip both of these. So we're going to go up, and we're going to go left. All of our dots make a line. We're happy about this. Get it in there. Here comes the one possible trick that we're going to run into, though. We have a problem. Even if I want to put this in the calculator, this second equation's not ready to be in the calculator yet. Because y needs to be on a side by itself. So I got to do one thing to fix that problem. How do I fix that problem? How do I move the negative 6x to the other side? Add it. And what I'm also going to mention with that is, you're like, well, is it okay if I put negative 3 plus 6x? Mathematically, yes. But we want it in slope-intercept form, which means we really want the x first so we don't get confused. But now that it's in the right form, if you're a graphing expert, graph it. Go for it. If you're not, if you're a little not sure about this, now we're ready to put it in. So 6x, again up here next to alpha, minus 3, not negative 3. Calculator's picky, I'm just telling you. And then second graph to get my points. And so I don't know about some of you how you're going to want to. Ooh, now see, like negative 1, 9, that don't even fit. So I'm going the other way. 1, 3. Holy cow, I barely have any that fit on the graph. What the heck? But what's the important thing? The one that I need is there. There it is. That's the one that they two have in common. Sometimes we're not going to get a whole lot of points in the graph. Like, really, we only had 2 that fit. That can happen sometimes. There's the x value of that point. There's the y value of that point. And I'm set. So, Hardy, will there always be a crossing point for every one of these? Most of the time. Not every time. We'll see. We'll see. Because we're about to see a couple of special cases. Most of your problems are going to be like these two. But when let's say we get to number 3. Now here, this gets a little more interesting. When we see x equals is always a vertical line, a line that goes up and down. Y equals, if there's no x around, it's just a number, is going to be horizontal. We saw that first semester. So, all I have to do, this is the easiest graph we're going to have. I go to where x equals 2. I make me a vertical line. For y equals negative 3, I go on the y-axis to negative 3. I put a dot. I make a horizontal line. And just like that, there's the intersection. That's all I need with all these is the intersection. And so again, to get my answer, find the x value, find the y value of that point, and we're in business. Now, we like seeing those. Those, there's not going to be a whole lot of thought to it. Should be there. Done. And if you really look, check this out. X equals 2, y equals negative 3. You actually can just take the answer straight from the points. The But that's the only time I can do that. So I got to be a little cautious. Okay, so I've mentioned before, almost all of them are going to cross at some point. But sometimes it's going to get a little weird. So here's the example of a little weird. So let's say I'm graphing this one. Okay, there's my y-intercept. Again, if you want to type it in the calculator and get points, it works. My slope is 3 over 1. So I'm going up 3 and right 1. Up, I technically can't go 3 right there, but I just did anyway. But when I run out of room, just flip the directions. Down and left. 1, 2, 3, left 1. 1, 2, 3, left 1. Make my line. Now this is normally where I start looking ahead and I'm like, okay, hopefully one of those 5 points matches. We're going to see. So I look and I'm like, okay, my y-intercept's -2, got it. Wait a minute though. One, 2, 3, 1. 2, 3, 1. What the? 1, 2, 3. Party. It's like a highway. Like they're running right next to each other at like the same angle and they never cross. So if they never cross, and this happens sometimes, that's going to be no solution. And that happens when the two lines have the same slope. The slope on both of these lines is 3, or 3 over 1. When they're the same, but the y-intercept is different, the b, you're going to get no solution. It's going to be the two parallel highways. Okay? These are parallel. So when the slopes are different, they're going to cross. When they're the same, one of two things is going to happen. Either it's going to be no solution, because they never cross, or you get into a funky situation like number 5. And this one's probably going to be obvious once we look at it for a minute. So again, I go to graph. And I'm like, all right, my y-intercept is at 1. Got it. My slope is 2 over 1. Two up, 1 right. 2 up, 1 right. 2 down, 1 left. Then I notice something. When I go to do the second one, it's the same equation. What the heck? If it's the same equation, it's literally the same points. Like, every point is the same. This one's the same, the same, the same, the same, the same, the same. What the heck? How does this work? Okay. So this one has infinite solutions. Like, there are more solutions than you could ever write down on the paper. Because they have the same slope and the same y-intercept. So when you see the same slope, when you look at the numbers in front of x and you see the exact same thing, one of two things is going to happen. If the y-intercepts, the b's are different, it's no solution. They're just going to cross. They're never going to cross. They're just going to run parallel. If they're exactly the same, you just write infinite solutions. You're done. Okay? You're already going to know what the answer is. So they can cross, or if they have the same slope, it's going to be one of our two special cases. So, here again, as we kind of get used to things a little bit in semester number 2, both for my veterans of dealing with me and my new people. Here's typically how this works then. We keep the notes in a nice convenient spot, like right next to where we're at. And then we usually just kind of slide over here a little bit. I'll slide these back up in a moment if we need to. And we grab the practice packet. And I have to make a confession. Actually, I have to make 2 of them right off the bat. Number 1, we had some issues down in the copy room. They ended up skipping my other cover page, so these are off. And also, this is on Hardy, I forgot to number. So, we're going to take a moment here. We're going to take a moment after the Hardy apology. We're going to number. So, that first page here, which is where we're going to be here momentarily, is page 1. And just as you keep flipping, so there's page 1, I flip over to the next page, there's 2, and you're like, okay, I get where you're going with this, Hardy. I've been able to count up to like 10 since I was very young. And we're just going to keep rolling. And we're hoping at the end here that we're all going to end up on the same number. Because if we don't, 5, 6. Normally I am much better about this. I think this only happened once all the first semester. So 7, 8, almost there. Luckily this is not a ginormous pack. 9, 10, last page coming. 11 when we hit the preview. 12 is the end. 12 is the end. So if you get anything beyond 12, we'll have to figure this out. Because the back of that last page is blank for what we're doing. I appreciate your help and your patience with me in that area. So this is the part, this practice part, is what I get from you when we get to the first quiz, which will be late next week. It just lets me see how it was going on the homework. Did you do it? Where's the issues coming? Things like that, so I can learn with you too. Now, if I don't see this, then I can't answer a whole lot of questions. So what we typically are going to do is there's going to be a front and back. So page 1 and 2 is what we're going to be doing here. And what you also will notice on a lot of the worksheets I have in here is I will put the answers at the bottom of the page. So as you do it, you can look right away and say, ooh, okay, that matches one of these answers, I'm good. Or, ooh, this does not match any of these answers. This is not so good. So here's what I'll do. I'm going to do number 1 with you. I just want to look at one thing quick. Okay. I'm going to do 1 with you, and then I'm going to have you do number 2 on your own and kind of go back and forth with the person by you and see if we're kind of getting on top of this a bit and seeing. Because there's one other piece to this that I'm going to want to go over with you, but I want to do this first. So number 1, we run into an interesting situation right off the bat. No matter which way I'm graphing this, okay, y equals 5x. There's not a y-intercept there. There's not a plus or minus number at the end. What number is there if I don't see one? 0. So I'm going to go ahead and I'll put that in. My y and my x here. So there's my y-intercept of 0. Make my slope a fraction if it's not one already. So we're going to go up 5 and right 1. Then I ran out of room already. That didn't take long. So instead of going up and right, I can go down and left. So I'm like, that's not many points, Hardy. It's not. You're right. Again, if you are a graphing expert, keep on graphing. If you are not, if you're like, still could use a little assistance, okay. We're going to type this into the y equals. And again, second graph, like it says in my notes, hopefully. And I'm going to start plotting points. Now, I'll get a question from people quite often, and I understand the question. Hardy, I already see where the connector point is. It's right there. Do I have to keep making all dots when that happens? And the answer is no, you don't have to. Once you see that, if you're good, and you get that in, you're good to go. And so what's that point? We're at 1, 5. And that's my answer. So what I need you to do now